Okay, my outstanding friends, this is going to be illuminating. What are we looking at here? Some of my specimens. And are these specimens CAT scanned? Yes. Are these specimens DNA tested? Yes. Can I show the anatomy? Yes. Can I show the chemistry? Yes. Let's see if I'm right. Okay, I'm making all these wild claims. Can I back them up? Yes, I can. This is a giant human hand. It's a left hand, and that is the tendon that runs right down from the pad here, straight it down. You have one too in yours. And this is the pad that runs off to the small finger, and that is the thumb. That's the cleave in between the two pads here. This silver stuff is what's called grip skin. It peels off. It's like a rubber glove that just everybody has them on their hands and their feet. And this is the pad, puffy stuff here. Now, I found the fingertips, knuckles, all kinds of things from this. And I had some of them CAT scanned and DNA tested. Well, I had DNA tested. I had several things DNA tested, 3. And they all came back human, and this was one of them. Now, this was small enough that I could get a CAT scan. This is a fingertip. That's just the tip of a finger. And here it is in the CAT scan. And this is what it looks like. It just looks like a big ball of mud. Until you understand what you're looking at. That's the bone. This piece broke off here, which is the tendon. Let's look at it from the CAT scan. That's this right here. All right, you'd have a hard time making out all these features if you didn't know what to look for. That's the bone. Now, this is what they call 2D CAT scan. They take a bazillion different pictures of it and put it all together, and using all the little ridges and highlights and all that, you can see every detail. That is a tendon coming up the side with the vein, and this one is with the artery coming up the side. That's the bone, and it was CAT scanned. And this is it. Now, this little hook here, you say, what the hell is that all about? That's where the tendons lock right in there. There's a tendon that locks right in there so you can twist your fingers around and do all that stuff. Now, this is so transitioned into mud, there's virtually, it's virtually completely transitioned. All right, you can see where the veins are and the artery and so forth, and the vein and the artery, and the tendons, and the bone. Now, that's a CAT scan of this. Now, this is a fingertip. That's like the tip of a finger, only it's a knuckle, a thumb. It's a left-hand thumb, and I know that because this part hangs over the side of a thumb. Only the thumb. You got that little bump hanging over. That's what this bump is right here. Right here. Just like this. There's the bone. There's the bone. There's the bump. There's the bump. The blood runs up both sides, and you have a tendon on each side, so you can do all that stuff. And I'm going to show you the anatomical stuff. It's undeniable. You see, that's where the blood runs up on both sides. You got the artery coming in, the vein coming back, basically. And there's where the tendons are too, so they can do this. Now the thumb, you really can't see much because it's just all blurred out with blood. There's so much blood in your fingertips. I call them the digital terminus, which is where your blood terminates. It comes out here, and what comes back is the vein blood going back to be recycled. At the tips of your fingers and the tips of your toes, you have these 2 little dots. And you have 2 dots on the side of each of them too, and I can prove this. All right, I said I can prove these little hooks. What they're for tendons. I'm going to show you that in a second. Now remember, this is only on here because this tendon here broke off from where the bone is. And when they actually do excavations, they find these bones and they chip off all the flesh to get to the bone. I'm not kidding you. I've been watching what they do. And they would chip this off because you can see bone under here. If you take this off, it's a different material than the bone. And you can see that in the CAT scan. You see here? You don't see much, but you got to really be able to look. This is just as it's starting to get into the CAT scan. You see this color difference here? This is the piece that broke off. We're right up to the bone. They would chisel all this stuff off, but it's actually the meat. They're just chiseling it because it really turns into what they call mud stone. Now, they would say, well, that's just mud. No, it is mud stone because once it was muddy flesh, bloody, muddy flesh. Mud and dirt and clay is nothing more than eroded mud from eroded flesh. The bone doesn't do exactly the same thing. So sometimes the bone does come out of the flesh, but not in these conditions from the Great Flood. The Great Flood was totally different. It boiled the oceans. It boiled off all of the fluidy stuff from inside the bodies of these creatures. And then, because there was an enormous amount of silicates all created and coming up, and the oceans boiled and cooked them, they transition. It's called nucleophilic invasion. So whatever was in the waters worked its way through the membranes and just turned everything solid. And in most cases, well, in a lot of cases, it just turned basically to mud, like mudstone. This is mudstone. Well, guess what else it is? That's the bone ball of a fingertip. And that right there is the muscle, and that is the tendon. And I'm going to show you that right now. But don't forget, this you can see. Now, I said the hook here, here's the hook. Right there. You see that? That's this hook. That's that hook right on the side. It goes right in there. And this is the fingertip that comes down here. And you see that? That's an apical tuft. That has all kinds of little holes in it. And it sits right at the tip of the fingertip. And a whole batch of little tendons come down here. There's a whole batch of balls in it. Well, guess what? Holes, I mean. And the balls go into the holes. I have one here from, everything I have is, I have some of almost everything. This is one of those. This is one of these eroded, right there. That's exactly what it is. And it has all these balls in it, and there's still one way at the very end. Now, this came off of a fingertip that was like this. You see that bone black pattern? I hope you can see that. There's a black pattern there, which is this pattern here. That's the pattern. All right, now on the sides, and here's that hook again. Remember the hook I showed you before? That's where the tendons lock in. That's this right here. Now, this is where there was a vein. That's where there was a vein. They clamp off. That's where there was a vein, and it clamps off. That's the artery, does not clamp off. Artery does not clamp off. Artery does not clamp off. And this is where they're fed. There's the artery, there's the vein. The vein still has a tube on it. And this was a fingertip, and it eroded heavily, I mean real heavily, all the way down to where you can still see the outline of the bone in there, if you see it. You see it coming up and around? That's just coming up and around. This is from another one. It completely dissolved. So that's not from here. This has its own inside. Now, here's one that didn't erode much at all. Very little erosion. There's where the hooks come in. I showed you all this stuff in the CAT scans and everything. Now, this is one of the knuckles. This is really the knuckle ball right under here. I'm going to show you this in a second. That's the tendon. And that is the muscle, the weave of the muscle. Let's take a look at that. All right, this has to be the coolest thing I ever found. This is a knuckle. That ball right there is the bone. And that bone is right there, underneath this tendon. Now, this guy died on his back, and his hand was like this, laying like this. This eroded so heavily and turned into almost solid mud. Well, this you can see is the outline of the bone ball calcium. All right, remember I showed you in the CAT scan, you could see the outline of the bone, but everything else was just turned to mud, and that's what happens. All of the really cheap stuff turns to mud. The heavy-duty stuff, the tendon, which is right there, does not turn to mud. And the bone, it turns to a state of mud, but it's a hard mud. And you can see quite obviously that's the outline of the bone. And this was where the marrow was. Now, so the guy, here's his, exactly like this. That's this piece coming down right here. This is the muscle right here. That's the muscle. And he died on his back like this. So we have this one side eroded so magnificently that we can see exactly how all of the muscle fibers came down, wrapped around the ball, and the bone ball is just perfectly exposed. Now, the other side, just the opposite. The other side shows every bit of the details. Here he is laying on his back like this. That's why it's as flat as a pancake, and that's because this is tendon. You see that? It's a very, very heavy-duty tendon. And that's what this ended up being, flat as this is. Now, this piece right here, coming down, is this piece right here. And they snap absolutely straight across, which is the abrupt transition, and that is the snap. I didn't cut that. I did not cut that. I had nothing to do with this. This came out of the ground just like this. The muscle is here, wrapped up underneath in here. All right, this is the fingertip that was CAT scanned, DNA tested, all of that stuff. Now, that's the part that is actually where the tendon goes up in here. And it's a different color and it's a different texture. This, you might be able to see, has this little bony, gritty little stuff that actually keeps this locked into it, so that it's stuck in there, like it won't slide, if you understand what I mean. When you're alive, the bone has to attach to this, and it does with these little bumpy spots. Just like, let me show you a bone here. You see, that's how they attach at the bottom. That's where this flesh engages into the bone. And then you go into your smooth bone. But it does the same thing at the top. You get that old bumpy looking stuff. And that's what this is right here. Now that's what they want to get down to. They would have knocked all this flesh off and thought it was just mud, when it's actually the finger. It was the finger in its entirety. And I've seen them doing this, regularly. I was watching them do some big fancy dinosaur thing, plesiosaur or something like that, and they chiseled everything away down into the gray clay, and you could see they just removed his body, but they took forever. Now, when I test things and get DNA tests done, I drill into them, into where there's blood. And don't forget, I know where the arteries and the veins are, and they are in the fingertips. They are saturated with it. As I showed you, the blood in the fingertips. Now, that is the fingertip that would be way out here. All right? Can you see that? Yes. Now, what else is way out there is the apical tuft, which is this. It sits way out here, and all these little tiny straps, if you can see them, they lock into these balls. All right, and that would have been on the end of a distal phalanges, which is this, and the blood is fed through, and you got your arteries that blow out because they're red blood. The black in the mud fossils, it seals right off. The black, that's where the vein was, right there. That's where the vein is. You see the different texture? You see the circle? That's where the vein was, and they just clamp right off. And that's where the vein was right there too, because they have one right at the very tip, the digital terminus, And that's the artery. They don't clamp off. They just blow right off. And red blood stays red and fluidy forever. You just put a little water in there and it just gets wet and muddy and bloody again. So far, we're into that far. Now, let's look at this little spot right here, which is the tendon abrupt transition from the knuckle. We're going to see the knuckle ball, the bone ball that's under there. And on the other side, it didn't erode. We're going to see the actual tendon coming down, and that center spot right there is this right here. Well, the whole thing is that, but there's a center core in tendons, and all tendons are like that, and muscles too, basically. There's a central core, and then surrounding it, there's a whole bunch of other stuff, but the whole thing comes up and snap, breaks right off at the abrupt transition. This is nothing more than that on the other side of this. Now the guy died on his back like that, or his hand was out like this. And this is what it came up with. A bone ball, quite obvious. There's the surrounding layer. This marrow and all that just turned into really slimy mud. This side still has the actual muscle fibers, just like that. It's identical. And it has the tendon coming down, and there's a core of the tendon right there. And that's how this is the fingertip, heading out. Pulls this way, pulls that way. There was one here, I believe, and it just snapped right off, just like this could. Or it might have been at one of the ends, I guess this finger here, it could be this finger right here, because it only pulls that way. Well, I don't know. You have to look at it a little deeper than that. But anyway, that shows that this was from this gigantic hand. So now you say, oh, Roger, nothing could be this big, 3 foot wide, 4 foot wide hand. Well, I got them much bigger. And by the way, that is a hair follicle. Same hair follicle as that, different shirt. Same hair follicle. Now, what is that hair follicle? Here it is right here. I showed you how muscles attach and how tendons attach. There's a spot on a muscle attachment here, right there. That's what's called the erector pili muscle. It makes your hair stand up on end. Then you got the sebaceous gland, which is this. That gives you a little oil. And then you got the root ball, comes down right there, and then you've got your hair papilla, which is the vein and artery at the very bottom, to service this to make it grow. And they grow fast. And that is 2 inches wide. All right, it's 2 inches wide. Now, our hair is not quite that wide. So there must be whatever kind of creature it came from. This is not DNA tested. I had 3 DNA tests done. All of them came back positive for human Homo sapien, mitochondrial bacterial DNA, which says it is from a human being. The 3 that I had tested. And one of them was this, and 2 of them were, one of them was this, which is a lung. And it's saturated with blood down here. I mean, saturated. You just drill down inside, you take it out. And it said it was excellent quality and dense. And they all pretty much died with this flat side because it was a great flood. And because of the conditions, that's the preservation. I wrote a paper in 2015 called Fascia, which is this stuff, facilitated fossilization. Fascia is nothing more than collagens, your skin, membranes, anything that's a coating of, like even this coating here. That's basically fascia. Everything has a membrane, a coating. Even my pet goose here, Caesar, his feathers are coating. They're made out of collagen and keratins. You see this? This is his feathers. That's the pattern in his feathers. And he tried same thing, flat on one side. And this is his neck. You can see the actual pattern of the bones in there. They chip all this stuff away to get to the bone. There's the artery right there. And here's his neck. It's got his little beak hole right there. And, these things are what I am claiming that they are. So I think it's time we should look at this with a more open acceptance of what we're actually seeing, and then examine it. Because like I said, I presented this long, long ago, including DNA, CAT scans, specimens, anatomy. Even I articulated the process, which was the Feldspar created from aluminum silicates, which is boiled down from phosphorus. Phosphorus is in the membranes. All membranes, 100% of them, are made of phospholipids, phosphorus fats, slippery phosphorus and fatty stuff. And then during the boiling process and the nucleophilic substitution, they changed into aluminum silicates. Well, guess what? Almost all rocks are coated with feldspar, at least. And the feldspar is 100% of feldspar is aluminum silicates with inclusions. You see this? Feldspar is any group of aluminosilicates, which is the aluminum silicates boiled down from the phosphorus. Feldspar makes up more than half of Earth's crust. And professional literature about them constitutes a large percentage of the literature of mineralogy. Yes, because everything was coated, all the membranes of all the creatures there are, and literally all the rocks that exist that I know of, that I have seen, are from body parts that were solidified during this great flood. That's why almost all of the Earth's crust is covered with these feldspars. Now, if you break into them, though, you see here, hold on. This is feldspar. But inside, they're not feldspar. That's inside of a body part, and that is the coating, which was the skin or the membrane around this body part. You see the black and so forth? That's, I think, a bone right there where the flesh met up to the bone. It's extremely eroded and so forth. But I think this part right in here is bone. And this is where the flesh met up to it. And of course, it's the feldspar is the aluminum silicates. And I believe that died like that. And I smashed it up to look inside and see what's inside. I do what you call brutal geology. Okay, so my claim is that all the feldspar is from aluminosilicates, which is from phosphates boiled down. This would be considered plagioclase feldspar. All right, so they break it down into two groups: alkali feldspars and plagioclase feldspars. This is from a lung, and these are little fibers in here, and they see those in the stuff, and they call it plagioclase. And they give it some special name, and then they find other things that are feldspars, which are all kind of muddy things that are from skin. And skin, it doesn't have, in some places in your body, which in a lung, it has to do this 24 hours a day, 7 days a week until you die. And then when you die, it turns into plagioclase feldspar in the right conditions, which was this in the Great Flood. And all of those little fibers they would call plagioclase. I don't know how they came up with this. Anyway, I can explain all of these different types of stone. They're very, very, very simple to understand. Once you understand, all of this stuff formed basically in the Great Flood. All right, they would call this plagioclase. But this is very dense plagioclase because it's the pleura on a lung. And again, the lung has to do this and really move a lot. So you need a good fabric to keep this thing together. And these are the fibers that do that job. And they're on your grip skin too, because you're always doing this with your grip skin. And they have to be tough, and they're tough. And this is another lung here. This one here actually had blood coming out of these little spots here, just a little tiny taste, little bubbles. And you can see all of the alveoli, there they are right there. All right, and then they have like slabs that cut across. That's why you see this here. You see? Anyway, this is the blood that actually came out of that one. And this was DNA tested. That's this one right here. And again, flat because it was in the Great Flood. And this right here is a latch that nobody really understood before, which contains all your fluids that are in this fluid-filled bag. That's a fluid-filled highway, which is the membrane. They transition from here into another set of the body that those fluids have to move from this bag to the next bag. And I think there may be different chemistry in this bag than there is in the next bag, because this might be moving to the stomach. You're not going to have the stomach acids exposed to the same liquids as a lung, I wouldn't think, but this is something that's never been tested. We'd have to see what is the different interstitial fluids in every different type of organ. And that might lead to why there's so many different cancers, because there's a cancer of the gallbladder, a cancer of lung cancer, kidney cancer, all kinds of cancers. So every one of them is an invasion through this surface. Anyway, that's a whole other subject. See, this is the go-to answer. Everything's magma. It all happened from magma, and it cooled down so fast that it did this, and it did that, and then this happened, and that happened. Well, it's not always magma, my friends. Plagioclase feldspars include members of albite anthrite solid solution series. Strictly speaking, however, albite is an alkali feldspar as well as a plagioclase feldspar. Well, let's see what we're talking about in plagioclase feldspars. I just happen to have one that happens to be a gigantic human toe. Okay, I'm sure this is human because the anatomy is exactly like ours. This would be a left big toe, and that is the callus. You see the size of this thing? Wait till you see this. That is where the toenail was. Right there. And all that black blood, as I showed you, blood is very, very dense with the black, the yellow, and the red. This side blew out, and that almost never happens. I showed you before. This clamps off, and that's the black blood. It should have clamped off. The red blood blows out, but the cap was over the top of this. This callus is so dense that it kept the red blood from blowing out, and it exploded out this side. That almost never, ever happens. You see that black stuff? That's black blood. This is where the toenail was. Right there, right around. All right, and this is where, your tip of the toe is. This is just unbelievably heavy-duty callus. This guy did not take care of his toes. It's all cornified. Now, you can see this. This is just the toenail. Now, they call this plagioclase. You see this stuff? You say, oh, that's plagioclase. No, it isn't. It happens to be grip skin. You see this stuff? This is what it is right here. It's these little flakes and fibers. And this is that toe. That's the bottom of that toe. And that is, it's a gigantic toe. And this callus is unbelievably dense. So plagioclase, I got it everywhere. And it is, again, this would be called plagioclase too. It's a lung, and it has DNA tested, and it was excellent quality and dense. So it's time to pay attention to the reality of the world. These things that were written about in the past need to be re-examined. That's all I'm asking. All right, prepare for this. This is what a fingertip looks like, and they actually break off, and they have their own surrounding inside, underneath the fleshy part. You come to a substantive part, which is the basement layer, and that really surrounds everything. And it will have a little bump sticking off the back because that's where your bones rock on each other. You see here? These are the different looks to it. And I showed you this here, which has that look to it right there. That one, this look right here. I don't know if you can see that. To me, I can see it, but I don't know if you can or not. Anyway, as you get down to the substance which wraps the bone, let's go to there, and let's look for that little stub. All right, you remember the fingertip, and there's the vein and the artery. There's the vein and the artery, and this circle right here is that little pad that it rocks up against so that they don't scrub. Now, this is a gigantic fingertip, and I mean gigantic. It's 3 feet long from the very back to the very tip of the front, 3 feet. It's about 2.5 feet wide, something like that, 2 feet wide. Maybe not quite 2 feet wide, but it's 3 feet long. All right, now, take your time and look at this very carefully. That is the fingernail. All right, it's obscured here a little bit. You really can't see it defined all that well. But here you can very easily, and coming all the way around, it's very well manicured. And the whole thing is perfect. Now, part of the layering has chipped off basically. So here's the full top. I would imagine that was the very top of the nail. And some of this has sort of scaled off, but left that little piece still of fingernail. Now, you cannot get blood from something like this that is so, this is hard, very hard. So I realized I had to go inside, and again, brutal, and I just smashed it with a hammer, and it popped off because it's skin. And that's grip skin. Grip skin pops right off. It's not even hardly held on there. It's just laying on you. And I'll show you the picture. And the grip skin still had some fingerprints on it down at the very bottom here. All right, right up by the edge of your finger. There's no fingerprints, but just real next to it. Right down here, they start with your fingerprints, and it was still there. So that's the fingertip. Now, let's look at the fingerprints and the grip skin, because that's what came off was the grip skin. All right, this is, where'd you go? Here you are. That's what came off. That spot I showed you on the edge of the fingertip. These are fingerprints. Those are sweat pores. The fingernail was up here, ran way huge fingernail. Now, my thumb is the width of one finger ridge, just like you have in yours. This is what peeled off. That's what this is right here. That's grip skin. It just pops right off. And under here, when mine came off, it was literally like a scab. It just popped right off. It's like you peeled a scab. And I got it right here. Hold on. All right, you see the bottom? This was what was laying on. Here's the finger. This was where the fingernail was. Way down like this. This is coming over the edge, and here's where the fingerprints start. You see them? There they are right there. That's the sweat pores. Now, underneath this, it's glued. It literally just like it's glued, just like that, like Velcro. And when it popped off, it just came off like this. There's no fracture there. That's like just a slimy, gluey stuff. But there is a fracture here, where I cracked in between here. You see the difference? That's inside the skin. That's inside the skin. This is the bottom layer of the basement of the skin, and this is the surface of the skin. and it's like pretty damn thick. And that's his fingerprints right there. All right, so we're thinking, and it's hard. There's what they call a Mohs scale, and this is way up there on the hardness. So I just showed you the whole thing, and then the piece I broke off, I just showed you was here. That's where the fingernail was, and going over that way was where the fingerprints are. You got every detail is here. It's a fingerprint. Plus, it came back saying excellent quality DNA. This was an excellent quality dense, because when I went down inside, you see how much blood is in these fingertips. And this was also excellent quality and dense, because I drilled right down into where the blood is. I mean, you literally took raw blood out of there almost. And the DNA tests were done very, very well, high quality, certified lab, and they did a fabulous job. And the archaeologists did not like the results. Now, don't forget, I pulled blood right out of his fingertip. It was a thumb. Well, no, that one there was just a regular fingertip, but they're all saturated with blood. Saturated. And of course, a lung, I would think you're going to have some blood inside of a lung. And the other one was this. Can you see that? No, you can't. This stuff here was the extremely transition stuff. The DNA from this was not as good as the DNA from the other ones, because it's almost completely nucleophilic transition into mudstone. But you could, the anatomy is so obvious that there's no question what it is, and the hand and all the rest of stuff. And it did come back positive, but weak. And the reason is, instead of drilling holes in these and going inside, I decided I would use this, because I could see red blood right here. Watch. That's the artery. And I could see red blood in there. So I just went inside there and scratched in there and used that just to see how much you could get. But it was very degraded compared to the other two. Well, you can see why. There's that black stain. I can see it there. I think you should be able to see it. And there's the vein and the artery. Veins clamp off. You still got the hook, just like the other one, and the red blood flows out. I didn't put those holes there. And here's the artery, the veins just clamp right off, because your arteries can go either this way, that way, back and forth, doesn't matter. Veins, when they come back after being used up, they got to go back to the heart and the lungs to get recharged. That's the difference between the veins and the arteries, is the direction of the blood flow. And of course, obviously, the chemistry. I think I made my case. All right, this is from the DNA test. Excellent quality DNA sequence obtained from the 36-inch tip. That's that gigantic fingertip with the grip skin came off. And the lung sample, which was just a normal looking human size. And they were Homo sapien, mitochondrial, cytochrome B gene, and D-loop region. Both of them. And this was a very high quality test. They did all the CTAGs, they did the DNA analysis, all of that stuff for mitochondrial Homo sapien DNA. And these were all the results, and this was a certified lab. And Biolab, Helix Biolab. This guy was fabulous to work with, very, very interested, and I think he may have paid the price for that, because when academia comes after you, you don't get away lightly. Now this goes back 10 years, and they still refuse to. They won't even look at it. Now I'd like to have Donald Trump ask Yale why they refused to examine this, because I did everything they asked for. I brought all, I did everything. They said, you need CAT scans, you need DNA, you need chemistry, you need this and that, and I did all of that. And in 2015, I had it all done. I presented it in a paper, It's on academia.edu. It's called fascia-facilitated fossilization. And the fascia is nothing more than the aluminum silicates, which is feldspar. Feldspar is fascia. And it facilitated the fossilization under these conditions, which I described in my paper. And at the same time, I was able to actually see this fluid-filled layer that nobody knew about in the body of these creatures that they're solid, but they stayed exactly the way they were when they died. In an autopsy, they drain them of this and they do this and that to them, but by the time they do the autopsies, the fluids are gone. So this one layer they never even knew ever existed until I found it basically in 2015. In 2018, there was a paper written about it. They called it a fluid-filled highway, which is what I said. It was a tubular, fluid-filled network, covered every part, and that was in my paper. Now, why wouldn't Yale talk to me about this? And I've tried to present this to Harvard, too. There's another one. He says, I tried to Harvard, I tried them all. Nobody would examine any of this stuff because it goes against God. I mean, it goes for God against them who hate God. I mean, I'm telling you right now, they just don't like it. First words out of the guy's mouth from Yale was, what are you, a creationist? And I said, what are you talking about? Because I think I hit him right off the bat with, I found giant human DNA, giant human fossil something, and it did not go well, not well at all. And I'd like to have Donald Trump look into that and say, can you explain your response to all of this? I mean, a school like Yale and Harvard and MIT, Johns Hopkins. I went to some of these places, and I actually interacted with the professors. I didn't actually physically go there. I took a course at Johns Hopkins, and that didn't go well. It was in genomics, talking about how. Anyway, none of them went well. Yale was the first one, and everybody said to me, literally everybody, said, well, you're right down the street from Yale. And I am, 15 minutes from Yale. And they said, why don't you take it to Yale? I said, they won't look at it. And they all just basically started laughing. I said, well, why do you think they won't look at it? Seriously, that's what they say to me. Why do you think they won't look at it? I said, well, because they don't want to see the result. Oh, I see. Oh, I understand. Yeah, I'm sure you're right. Well, looks like it's time to get a cup of coffee. See you later. And it was basically the same thing. They all said, go to Yale. I said, I've been there. I did everything they asked, and they won't examine it. Now, I think Trump's got to look into that. And I know that, I don't know this for a fact, but I've been tipped off to the fact that they might have about 40 billion tax-free dollars laying around. And as far as I'm concerned, you should be doing your job. Charging that kind of money to teach kids. I would assume you'd want to pay attention to something that was pretty well supported like this. So anyway, I'm waiting to hear from President Trump or Ghosh or any of them. I just showed you the evidence. If you can't take that evidence, and not only that, Ben knew that they went out to, I know exactly what that is, and they won't comment on that either. These are our national laboratories, our science networks, and they do not work. They do not work. They have a dogma that you have to stick to, or they'll put you outside of the realm of science and say, this guy's a nutcase. That's what happened to me, but I don't care. It's been 10 years. I'm going to keep doing it until I stop breathing oxygen. I don't care. So anyway, I just showed you my evidence that crushes, obliterates geology. And it opens up a whole new door to the ancient texts and the myths and the things that we always thought were religious mumbo-jumbo. And everybody in the world, 100% of the entire world, had all the same stories about dragons and monsters and giants and battles in the heavens and gods and eternity and hell and heaven and the light, and all of this stuff was not just one place or another, and they were not intermingled cultures. Velikovsky did all the work on this in the book called Worlds in Collision. I wrote a book about him 10 years ago because he was destroyed by the same people that tried to destroy me, and they're going to fail. I will win this, and you will help me. All right, I need somebody to stand up and start talking about this, and don't be afraid to open your mouth. It's spectacular, it's crazy, and Jesus Christ himself said in the Nag Hammadi text, it says that search, seek until you find, and when you find, you will be disturbed. And then you will. This just gets getting crazier and crazier. That thing cut right off when I got to this point here. This is the Gnostic text, and this is the Nag Hammadi library. They just discovered in 1945. It is unknown to history until 1945. There's a couple obscure, there was the Berlin Codex and some other little obscure things about Gnostics, but basically they were written out of history. But in 1945, they uncovered all these jars full of these literally books, actual books, codexes. And there was just like 50 different volumes, I guess, something like that. Anyway, I was just reading one of them. Right away it says, whoever discovers the interpretation of these sayings will not taste death. Everybody dies, so not tasting death means you have a spiritual life. Now, Jesus said, number 2, this is the one I was reading, and it cut me right off at the very end. Those who seek should not stop seeking until they find. When they find, they will be disturbed. When they are disturbed, they will marvel. And that's where I was cut off. The card ran out. Exactly at that word. And they will reign over all. They will reign over all. And this has always bothered me. How do you get that? They will reign over all. What does that mean? After they have reigned, they will rest. Well, as I keep reading and reading and reading in history, there was rulers put in place for some reason by the gods, the little g gods, big gods, I don't know who. But they put these rulers in place, and they reigned, and then eventually they rested. Everybody's got to go back to their resting state, I guess. But where would they reign? Then I remembered about the statement about my Father's kingdom has many mansions. Well, maybe you get a mansion. I don't know. You see this? Jesus said, if they say to you, where have you come from? Say to them, we have come from the light. We have come from the light. From the place where the light came into being by itself. It established itself and appeared in their image. If they say to you, is it you? Say, we are its children. We're the children of the light. We are the chosen ones of the living Father. Because light goes everywhere. And a lot of it doesn't turn into people or whatever. We are the chosen of the living Father. That gives you responsibilities. If they ask you, what is the evidence of your Father in you? Say to them, it is motion and rest. Motion is energy. It's energy. And rest is the same particles, just not doing energy. It's potential energy versus kinetic energy. Both the same, and both come from light. Jesus also said, whoever has come to know the world has discovered a carcass. And whoever has discovered a carcass of that person, the world is not worthy. And he also says the same thing about the body. I think it's number 80. I have to go through this again now after going through Pistis Sophia. Some of this stuff is starting to make a little more sense. Before, it's just total craziness. Jesus said, whoever has come to know the world has discovered the body. And whoever has discovered the body of that one, the world is not worthy. Let one who has become wealthy reign, and let one who has power renounce it. Jesus said, whoever is near me, being near Jesus, is near the fire. And whoever is far from me is far from the Father's kingdom. So you're about to be roasted if you try to speak up. And believe me, that's true. Jesus said images are visible to people, but the light within them is hidden. We're made out of light. It's hidden in the image of the Father's light. He will be disclosed, but his image is hidden by his light. We're made of light. Jesus said, when you see your likeness, you are happy. But when you see your images that came into being before you, and that neither die nor become visible, how much you will have to bear. Yikes. Adam came from great power and great wealth, but he was not worthy of you. For had he been worthy, he would not have tasted death. So Adam died because he didn't do what he was told to do, I guess. Or what is his obligations. There's obligations to be a living creature. I mean, that's pretty important when you look at all these things that, you know, the light is the key. I don't know. It's very confusing. I'm sorry. I won't babble on about that. But it does say all these things, and it says right here, it says, know what's in front of your face. What is hidden from you will be disclosed to you. There's nothing hidden that will not be revealed, nothing buried that will not be raised. That's why I'm speaking up. He says, Jesus said, everything's on the table. And I mean everything, and I'm saying everything, and it sounds insane, but it's true. I speak on a material realm. And another thing Jesus said is to have the Spirit, just have it because you're just, you know, you're enraptured with God, is great. But to have that Spirit injected into you because you found it from material existence is a marvel, basically, is what it says. I forget where it is, somewhere in here. Wow, this is just crazy. I have cast fire upon the world, and look, I'm guarding it until it blazes. That's what Jesus said. He said he didn't come to necessarily spread peace. He wanted whatever. Jesus said, this heaven will pass away, and the one above it will pass away. Now listen to this really careful, because this goes into Dipole flood. It says, the dead are not alive. All right, so the dead are dead. And the living will not die. The dead are not alive. So some are going to be dead and they will not live. The living will not die. So if you're living now, you will not die. If you're one of the corpses that Jesus said, you look at the world and it's a corpse. That's the people, I believe. And he said, these are the people that are dead. The dead are not alive. They're just walking around dead. And the living will not die. You're walking around thinking and living, you're not going to die. Now listen to this. During the days when you ate what is dead, and that's all you eat is things that were dead, you make it come alive. So it goes from dead into living. When you are in the light, here's the key. When you are in the light, what will you do? You're in the light now. On the day when you were one, which is the light, because the light is only one. The light is one. All right, so on the day when you were only one, you became two. When you became alive, you took on a material existence and the spiritual existence, with the white and the black. And it says, but when you become two, what will you do? In other words, will you become a sinner? Will you become a disciple? Will you be? What are you going to do when you come down to this material realm? That's how I'm taking this. There's so much you can read into this. You might be able, you know, it might be just crazy thinking, but dipole electron flood theory shows me that you can separate the white from the black, and the black is all the matter. And that's all they ever talk about. I say you want to get away from that matter and turn into the light. It's just as clear as that. All right, Jesus said we come from the light. Well, what is the light? The light is that bright stuff. And where does that bright stuff come from? From this particle here. The black stuff is mass. That's matter. It's like a bowling ball. You can't make it bigger. You can't make it smaller. It's just mass. And it attracts the white desperately. Well, the two of them want to be together desperately. That's why you see this arrangement in photons. This photon is moving through the air at the speed of light, basically, which is, the speed of light is not consistent, so let's not bother talking about that right now. But we found these particles. This is the glowy one right here. The black with the glowy edge around it is right there. This is very, very clear. Very, very clear. This one has virtually no mass. That has all the mass. That is dark matter. That's where you stand on. All right, but they are detached together. A single dipole electron would be the white and one black. That's what a dipole electron is. And two of them back together, back and back, make up a photon, which is light. And that bounces. It has a field surrounding the entire thing, so it bounces as light. An electron, a dipole electron, has only like a half a field. And it wants to be either joined to something or flow into something as heat. A dipole electron is heat. All right? It's not electricity. Electricity is just the white. Okay, now the photon in its own self is stable, and that's why we can see light and it does great things and so forth. It depends on how fast it's spinning and what it concusses with, what color you're going to see back. The same light gives you all kind of different colors, just like the same light space. Looking at this, there's all kinds of different colors. Why? It's because there's different layers of molecular bounce. Think about it that way. There's molecules all over that thing. Some of them bounce real hard, and some of them bounce boop. Some of them go bing, some of them go boop. The ones that go bing, those are the blue. The ones that go boop, those are the red. And that's why they are different frequencies of bounce. You know that. When you click some things together, they go bing. You know that you're way up here, and when they go doof, you're down here in a very low frequency. This is the only part you can see. All this stuff is here, but you don't see it. It's just everywhere. Anyway, we can see the light particles actually separate. So Jesus said, you're one, and then you become two. Well, if you just became solid white light like this, and then all of a sudden, boop, you're in the material universe, you become this way. Before that, you were just a white. So when you're one, and then you became two, what will you do? Because now you're in the material universe. Now you can do anything you want with your matter, good or bad. That's the way I'm going to take this. It's one way to look at it. Don't forget, this seems pretty clear to me. It says, when you are in the light, what will you do? On the day when you were one, which is in the light, you became two. You actually were literally born. When you become two, what will you do? So now that you've become the black and the white, you have a material existence. What are you going to do now with that? I'm going to go with that.